Yep. Okay, it works. Yeah, thanks for coming to the last talk. I will talk about some of our designs and historical decisions we made in the last years. So first of all, most of the technical stuff we did was work from Sebastian and Achim, which are also here. But I do the talk. So if something works, it was their job. If something not works, probably it was my job. To the agenda, I want to talk about something, what we do, some introduction of what NETWAYS does, some of our history, what we tried to solve our problems in our architecture, what we do today, and some stuff regarding configuration management, monitoring, and reporting, which makes it as a roundup solution for our company. So NETWAYS is a company with about 40 employees, located in Nuremberg in Bavaria. We do open source since 1997 and specialized also in open source systems management and data center solution. And like everybody does, we are searching for awesome people. So there are empty spaces. This is probably the field of our expertise. We do open source systems management. On the left side, the majority we do here is monitoring Nagios and Isinga, configuration management, service management, and all that stuff. And the corner where OpenNebula is located in our portfolio is the open source data center area. As well, we do managed service, and the setup I tell you about is what we have in our managed service environment. So this is independent from consultancy stuff we do. It's our data center environment we have over there. So we do conferences as well. We do OpenNebula Conf next year in December. So first of all, we do some puppet camps and various stuff. So check it out. An introduction to OpenNebula. Decided not doing it because I think it's the end of the first day. So if you're not going to get it until now, then it's your fault. What's our use case? So normally in our data center, customers are coming that have, most of the time they started with one machine. So they're coming from a public hosting provider, but their needs, their performance issues, or their problems they have are too more special, and they need to do more work on it. So we focus on solving that the open source way if possible. So most of our customers really started with one server. So for example, the biggest growth we had in the past was Stay Friends, which is it's a social school community platform. They started with one server in I don't know, a couple of years ago. And at the end of the day, they had about 450. So most of our customers start with a single environment with a virtual machine. Then they need more of them. Then we have a load balancer in front of them. Then perhaps they have so many I/O that we create DB servers which handle the database traffic. And if their environment gets larger, they get perhaps their own private cloud. So we move them normally from small to big environments. This is what we do regularly. Audi probably we didn't bring them. They build their cars on their own, but it's also something in our data center we do. So the requirements we have are automatic failover. We didn't have that in the past, that if a hypervisor goes down, the machine is up automatically. So flexible resources, though the stuff we have, the servers, the storage, that you can really flexible reassign resources to customers and also isolate noisy neighbors. Normally, the customers pay less the money, make the most of traffic and trouble, because they have one virtual machine and an unpatched Typo 3 installation and a buggy WordPress, and then they're doing a lot of UDP package all over the world. So this is definitely a challenge we have, and this is also these type of customers, the people that NETWAYS love most. If they have an unpatched WordPress and it's going crazy with some malware stuff, most of the time it's the WordPress installation of our boss or something like that. So we have to deal with it. And what was also important, we want to have an independent storage architecture. So we don't want to have something binded to a specific storage type like NFS or iSCSI or Swift or something else. We want to be flexible in that area. And from the perspective to our customer, every customer in our data center gets an own VLAN, and they are totally isolated, backup, monitoring network. So The requirement is that everybody can work, we can access everything transparently, but they don't see each other. When I came to NETWAYS, it was in 2007, we had a 100% bare metal system. So the only thing I knew about virtualization was about some microsystem virtualization, buying a big machine for millions and then creating virtual instances on that. That was my only knowledge about that. And everything, every web server, every load balancer, everything we had was on bare metal. It comes to our mind that it's not a good way. And so we started with Xen on an NFS. We bought a NetApp filer, which was, from one perspective, was not a bad decision because it solved our problems. But it doesn't scale from the financial aspect. So if it's if the disk is full, it's no problem. You can buy a new shelf, but you have to buy a new head because the CPU is old, and so it's you're buying a new shelf, a new head, a new shelf, a new head, and then you spend a lot of money. It works. It's a good product, but financial scaling is horrible. But we still have one, the second instance for now. It works, it does a good job, but it's too expensive for what we really do with it. So this is what we had in 2010, but we had a lot of problems with it. So the first thing, we don't have any overview about what's going to happen. So if an hypervisor goes down, we do that monitoring-driven reboot. Somebody knows what it is? So you're checking your iSinger and Argus, checking out the red lights, and then checking what machine to boot. And then you see if it's down, then you boot it up. The next is down until you have a green field. So we did this via Jabber. And do you boot this machine? Yes, I do. Oh, I boot this also. It's up twice. So we did that manually handling the machines, which was horrible. So we also didn't have any priorities. So we booted up and handled the machines in a totally different and free way, which is not good because we also didn't have any logic grouping. So the only thing we did was, how can we bring the machines back up very fast? Another problem we had is with Xen in these times was also we used Debian as a operating system, and we had often problems with the Xen kernel part, also with our Dell hardware we used this time. So this was a lot of time, it was really crap and it was unstable and we had a lot of problems with it. And no API. So accounting was a big issue. We don't have any accounting for our customers. We had a lot of scripts and stuff like that, but yeah, we were sure that it's not that which brings us to the future. So what now? It had nothing to do with bashing OpenStack because I'm not good enough in OpenStack to bash it. It would be a pleasure to do it, but I cannot do it. And these comparisons, somebody of the Rackspace guys did it, so this is probably not my thing. And he said, OpenStack is more like a base cake with you can do everything, but you have to do everything. And OpenNebula is more like a cake with chocolate and strawberries and everything works well, which probably you have to do some work on your own. But our focus was we want to have a framework which does our work and not hiring 20 people taking care of our framework, which should make life easier. We tried Eucalyptus as well. We never get it to run stable. It crashes sometimes everywhere. I don't know if it's better now. If somebody has an experience with that, the last thing I heard, they have problems with it. Walrus, which is memory leaking at the moment. I don't know. Somebody has experience with that? No, great OpenNebula conference. Okay. But there are two perspectives on that. So from a technical guy, you think there's a tool for every customer. And the sales guys say there's a customer for every tool. So if you like something else, you can try it out. You can do it. But we decided to go that way and choose the OpenNebula in 2010. The initial reason why is because Julian, the company owner, met Tino over in London, and he came back and said, we have to use this. I said, oh no, not another framework. We invested months in checking the other ones, and they are well crap. And no, I talked to him, and he said everything works. So we tried it, and yeah, it works now. So how does the architecture look today? It was a screenshot for our running instance for one of them. Yeah, numbers. We dropped Xen. We moved everything to KVM because it makes life easier. We don't have any big performance issues or something like that, but handling KVM is much, much easier. It works. And we are still living in that environment I'm describing about, it's about 6 hypervisors we have. We still live on that NFS filer, which works. We don't have really a lot of traffic there, so we don't have any DB instance on our cloud. It's more like web servers, also some Windows stuff with, I don't know, yeah, creepy Windows software, but it works. Terminal servers, all that stuff, it works. So totally mixed up from bug tracking from our website, different projects we're hosting. So it's a totally mixed environment, but it works very well so far. The challenges we have, that failover situation, we had that problem in the early days. So if libvirt or when a hypervisor goes down, to know, is the machine really, is it dead or seems to be dead? What's up with the network connection? That was a problem. We want to get rid of the NetApp, so this is something we're still on the road, that we can remove that filer. We will never get this machine down because there are so many customers on it. Say, yes, I migrate my share tomorrow. They will never do it. So the financial scaling perspective is definitely a point. And a challenge we have is choosing the right file system. So we started with Oracle file systems I worked with in the past, and I thought it was a good idea. I don't know. The first thing we started, every time in our lab, it worked very well. In production, sometimes it hangs. And we had problems that nothing happens anymore, and we have to reboot all machines. So we were not lucky. I had a lot of good experience with OCFS in a database environment, but using it as a cluster file system for distributing the images didn't work for us. Then we saw Ceph is coming, and there is a Ceph support until version 4, I think, in OpenNebula. And the basic architecture and the thinking of how Ceph works and scaling works, we think, OK, this is a great idea. Then we talked to a lot of people, and how did it work in your environment? And they say, it's perfect, it's great, but we have an event handler which checks the memory consumption of some mon daemons, and then we restart it. And then we invested a couple of months that we can handle it automatically, and now it works. So we have the feeling it's not really perfect stable. Let's say it's perhaps a pre-alpha beta version. I don't know. So it should work. The Ceph-FS is not stable yet. It's still in the beta version. I think the idea and the concept of Ceph is great for us, but all the people we're talking to, they invested a lot of time bringing it to a stable point for them. And so in this phase, I would say, perhaps we take a look on it in a couple of years. For now, we decided to do it with cluster-FS. So what we have at the moment, also problems with cluster-FS. Nothing of that technology is easy. The implementation is not probably finished, I would say, in OpenNebula. This is probably a point we want to work on. But the general idea is good because we still have access to the file system. We can still see it. It seems to be easy to handle. We built it up an instance about 2 data centers now, which works really good from the performance perspective. And we have to fix the remaining issues so far. So how we solved that? We have everything is under a pacemaker stack. So every hypervisor is controlled via pacemaker, all the resources. Very important is also creating libvirt as a resource, because we have that problem that libvirt crashes. And then OpenNebula thinks the machine is dead as well. And then restarting the machine somewhere else. But if it's on a shared storage, then you have that machine's, you need a backup. It's good if you have a backup then. So because it's running twice, and you can check your file system, and then you have different files on different machines, which is crap. So this is something we learned out of it, bringing libvirt under cluster control. So for now, if something looks creepy or something like that, we shut down the machine, and OpenNebula takes care automatically booting the virtual machine somewhere else. This works really fast. So our normal check interval from the monitoring perspective is about 5 minutes. So if an hypervisor goes down, normally we don't see as many alerts from the virtual machines. We hopefully see an alert of the hypervisor goes down, so a hardware message, but the machine goes up in 2 or 3 minutes somewhere else. So this happens at night. Nobody has to do work. And this is a big step for us, that we don't have to reboot machines by hand at night. Yeah, still working on NetApp. This is what we're running for now, but definitely on the road is that we go somewhere else. I think I talked about that, yes. Reporting and monitoring. In addition to the base monitoring we have in OpenNebula, we monitor everything with Isinga. Anybody knows Isinga? Awesome. So it's an Argus fork. Some guys of the German community and also NETWAYS forked it in 2009 and working heavily on that for now. So we're releasing a new core in October, which is multi-threaded and has cluster support. But this is still the old core with traditional Argus checks, where we check something like, do we have a stale NFS or other cluster resources working well, CPU load, so all the basic checks, also checking the hardware, graphing it, putting everything to a graphing database in addition to the standard performance measurements we have in OpenNebula that you can really see a long-time measurement of our machine. So far, we always have memory problems, so we never have CPU problems. We put in memory, but then one day memory is empty, and we have to buy new machines. But CPU is idling all of the time. This is what we see so far. So I think we can do everything with a Palm Pilot from the CPU perspective, but we need a lot of RAM. Reporting was very important because every customer gets a report. It's based on Jasper reporting. So we have individual reports based on different facts like monitoring, like traffic, and also for this perspective, like cloud resources. So we build a script based on Ruby. Is that right? Yes, awesome. Script based on Ruby, which gathers all the data out of the OpenNebula database, and then we bring it into a small data warehouse we have. It's a simple database schema where all the different tools and stuff we have comes together. For example, we have our customers in a sugar CRM, and then we have an own module where we created something like contracts, which is an individual model based on sugar, and then we created all the IDs and loading that together into a simple database model, and then we have everything together to query it and creating Jasper reports. And that also, this is a sub-report in Jasper, creating the OpenNebula resources. There's a summary report the accounting gets. At the end of a month, the customer gets his receipt based on that numbers. We can also do then availability report. So availability of the platform is also something coming out from the monitoring. It's in the Jasper report as well. And also the graphs, which are created with Node.js. So it's JavaScript graphs, but we created with Node.js and integrated based on the client ID, which is just an increment ID. And then we put everything together, and the customer gets about, I don't know, 20 pages, 200 pages, depending on whatever he has. There are tickets. We're using RT, for example, for trouble ticketing. We put in the RT. We put in the time track. So if we build hours on the customers, everything is included in that. I think if we started with reporting, I brought that into the company. Most of the people hate me for that. I think this has not changed until now, but there are PDFs coming out. Configuration management. We do everything with Puppet. Somebody don't know Puppet? Is it somebody don't know Puppet? Don't be afraid, you can say it. Yeah, then just read it. What's interesting is the live management using mCollective, but I came to this later on. So in short words, it's a config management based on Ruby. You have a language where you can define how a service should look like. And then you have the different phases, which Puppet says define, simulate, enforce, and report, that you define a service, you test it, you put it to another stage, you push it out to the servers so you can run it with a master mode or just the client side, and then have a report in that. So you have different interfaces for that. There is a Puppet Enterprise dashboard, which has a really, really good live management integration. This is good, but it's expensive. On the other hand, if you need support as well you need enterprise support, it could be an option. But otherwise, you can use Foreman. It's an open source project. I would say now controlled and then also sponsored by Red Hat. They build their satellite infrastructure around it in the near future. And this is what we use. Because one thing we need was the unintended installation. We use FIE, fully automated installation for Debian in early days, but yeah. And now we use Foreman. So this is just a filter on our hypervisors on that, where we can see what type they are. We have all that custom facts in there, and we created modules. So for example, OpenNebula or Pacemaker, everything is a Puppet module. So if we bring in a new hypervisor, we put it into the data center, we assign or use the MAC address, create a new host in Foreman, then it gets bootstrapped, gets the Pacemaker package on it, then it's integrated in the Pacemaker cluster automatically, then we put on the OpenNebula software, and also, for example, the 1daemon and the Sunstone interface is all the cluster resource, which runs on one of these machines. So every hypervisor is able to run the 1D and the Sunstone interface. So what we do is we configure it. We do a dry run using mcollective, so we can do it live. It's a RabbitMQ-based protocol where you can directly issue a command on the client side where we can configure something, test it, see if it works, and then everything goes to a Git. We merge it together, bring it to a new environment, and do a final test, and then we bring it out. So we define something, test it using mcollective, that we have an immediate result of it, merging it into the Git, bringing it to the next stage, and rolling it out. Works very good. We are working on a new OpenNebula model together with a customer of us. It's a big German mail delivery service. And with the OpenNebula guys, we hopefully bring that on the run in the next weeks, that we have something which is not perhaps a NETWAYS special module. Like every module starts very special with your own variables, names, and you are Schaemberg most of the time. Another thing we have on the road is doing our load balancer configuration. We're using LVS and LDirector as a load balancer. And I think this is still working, configuring out the load balancer automatically. So if a customer gets a new app server, for example, we also, with external resources, Hyra and PuppetDB, configure the LDirector services that we have the load balancer configuration as well. So coming up, what we have to do is update to OpenNebula 4.2. This is something we want to do, definitely. Using ClusterFS for production. I checked out, I'm not really good in it, but I think it's in QEMU 1.3, but you need a patched libvirt, so it's a little bit challenged to build everything together. But we had first promising tests, was something we investigate further on. So fully automated provisioning. So we want to take the next step. So for now, we have the control about the virtualization. We want to go to the network level, doing backup, monitoring, everything with Puppet, fully automated. At the end of the day, coming to that a new customer comes in, we put in the machine, add it to Foreman, and then everything from scratch, all that related infrastructure environments comes together and work. Yeah, kicking out NetApp file definitely is one target for my personal. And hopefully adding new nodes. And then it should work. So this is, I think I'm in time. Perfect. So time for questions if you have one. I hopefully can answer it. And definitely note the date for next year.
Yeah, you were talking about separate initially. Did you use the RBD?
Sorry?
Did you use the block box RBD?
Yeah. I'm repeating the question for the streaming. The question is, I'm talking about Ceph, we used the RBase. No, we didn't use it. So the problem is that we saw that this would be the way for OpenNebula, but we want to have a general solution for, because a lot of our customers just want to have a central share, a central NFS. And we are searching for a solution where we can have both worlds. So something like a Ceph, a block device where we can have for images. And this part of that is, I think it's great. It's rock solid, I think, but I don't know. But we also want on the same platform something like an NFS share. And it's always a problem. We want to have all in one box, then it's getting hard. And perhaps it would be a better thing to say, OK, we use R-based block devices for OpenNebula, and we use something else for the customer shares, but we are searching for some. For example, now we can, in cluster, create volume in Puppet, and then it creates the bricks, announces the NFS share, and everything pops out automatically, and this is what we are searching for. But you're right, RBase is probably the Radeon block device should probably work. I don't have any production experience, and we never got this way. So we did 10 phone calls. No, we did 2 phone calls, and then we decided, it looks good, but no, let's take something else. Do you have experience with that? Okay. Yeah. Okay. Perhaps they change it tonight. I'm afraid. Yeah, probably. It could be. So the main target is being independent. So perhaps if ClusterFS sucks next year, then we drop it out. Yeah. Something I see if you go, for example, to the bug tracker of Ceph, and you see something like in the current releases, I created a file and it's not there. Then it's like, this is the basic step of a file system, doing a touch and then seeing it in the list, which is can do with my basic Linux knowledge, so for example. And this makes a little bit, the trustworthy in that was not so good. But if you can handle it, I think the idea is absolutely great. But anyway, the great thing also, our decision for OpenNebula was that you're not binded to that specific. You don't have use, not bashing Swift, for example, not doing IceCasing, not doing that. You can do what you want. And if you have an NetApp, it's okay. If you do have an EMC or IceCasing or cluster or Ceph, you can use it as well. So if you find something new, then we kick it out and take this. Right. We separate them a little bit. For now, this is the main instance. We have one for testing as well, and thinking about another one where we can use in an virtual data center and the other, I don't know. Yeah, it's not. We have a customer which probably has its own machines, and they want to control it on their own, but we still want to have that central overview on that. And this is something where we're thinking about having a distributed instance over there. But now all that customers we have in our data center working on that platform, different VLANs, different user groups, they all have their perspective and don't see any other environment. Right, yeah, correct. Other questions? The question was how many people are managing that infrastructure. So in our managed service team for now there are nine people. There are 2 trainees doing the base architecture. So we have a project team, which is probably Sebastian and Achim. They're sitting over there. So we don't do any project at the moment. We have 4 guys taking care of the support. So there's coming in everything else. So handling the daily business. We also do a lot of like the Nagios and Isinga support in the managed service team. So I think for now in that phase nobody's taking care of that environment for weeks now. I think that it's running. Nobody's taking care of that. So we're monitoring it, but nobody works on that effectively. So we're doing a project, for example, bringing in cluster, then we're doing the next project, bring it into the production, then we're taking care of that. But I think investment of daily work after project launch, it was about daily 15 minutes maximum. I don't know. So no daily work on that.
Do you have any special flagging for IT to do monitoring of your machines installed in OpenNebula in order to automatically vision like that?
The question is if we have any special plugins. So for now, not. So we thought about creating a special plugin, but all the base services over Nebula, also the database is used, the daemons, libvirt, all that. There are good plugins on the market we use. So we use just standard plugins for monitoring a process, monitoring libvirt, monitoring a stale NFS. Perhaps it makes sense to write a plugin where you can perhaps use the API to bring more information about the runtime. That's true, but this is something we want to do in Puppet. So we want to control Puppet to tell OpenNebula, hi, create a new machine, and monitoring, you have to add a new machine to monitor. So we don't want to have a self-logic in the monitoring system finding out there are new machines, because we think that everybody thinks that is what he's doing is the best case, but we think the best case is to have a central point of configuration where we describe how the load balancer, firewall, monitoring, backup, everything should look like, and then Puppet runs out and creates everything necessary as well as the monitoring checks, then dynamically added to Isinga.
Do you integrate your configuration management into OpenNebula automatically?
So the question is if we integrate our config management into OpenNebula automatically. Do you mean controlling OpenNebula?
So who is triggering the configuration management if a new VM gets created?
Okay. So the question is who's triggering the configuration management. For now, it's a manually process. So we don't have a lot of customers, so we don't have thousands. We have about 40. Everything is special, and we do the whole operating sometimes in an only 24/7 shift and all that stuff. So if we have a new customer, we go into the big pre-sales phase, and then he's coming in, and then we create that manually step, create him in, create the contract stuff we need in Sugar, for example. But and then somebody gets a ticket and say, okay, we have a new customer. What's necessary to be done? Then perhaps we have to order some machines because he needs to have an SSD bare metal for some database stuff. And then we're creating that project. And if he needs virtual resources, then in Foreman we create a new host, say which distribution should be on that, CentOS, Debian, whatever. What Puppet modules, so we have some base classes for our stuff like SSH keys, monitoring, backup, blah, blah, blah. And we have some customer-related classes for their Tomcat, JBoss, whatever they need. And then we create the new host, for now not with the API of Foreman. So we create the host manually, and then everything, the rest is done automatically. We are bootstrapping, base module, and then installing all that customer stuff we need for that. But an ideal setup would be creating a new customer for us in Sugar and then launching up an AP call against Foreman. But this is something perhaps we reach in the next step. Okay, I have one last question. No, I don't have one last question. Perhaps I have one last answer, but some of you has one last question. Yeah. Yeah. So the question is if we have doing automatic configuration of Isinga and Puppet. So for now, the case is that there are really good modules for Isinga and Puppet available. So for now, the configuration language is still compatible. So you have that Isinga CFG and Argus CFG. That's probably the main difference. This will change in Isinga 2 because we have a new configuration format in Isinga 2. And one thing we have to do is we also will provide a Puppet module for that. Reason why people will hate us bringing a new config because everybody hates Nagios and say it's crap. But everybody uses it because it's so simple and you can use a plugin, try it, okay, it works, forget about it. So this is something, it's a maturity because it's easy to use. And the big problem is that everybody is familiar with that config, but it has big limitations. For example, that you can only add one IP address to an host definition, which is bad. And for example, in that Isinga 2, you have totally free macro definition. So you can add in Isinga 2, you can add 100 IP addresses to one host if you want to. And this is something where we have to change the way how to configure it. We are external resources and iterate that. But I think configuring Isinga should be work really well if we have a good model for Isinga 2. But for now, the model is existing there. There's a not so good on Puppet Forge, but there's a good from Grispo from Inuits. They have it in their GitHub repo, which is great. It works really good. Sometimes it's not so easy if you have because we don't have that application like 20 app servers and everything looks equal. Then using Puppet for configuring monitoring is easy, but every server is special a little bit. And so it's hard if you have 3 web servers on it doing everything in Puppet. For now, we don't use it. We use an LDAP-based configuration tool, but we want to come to that point where we use it with Puppet as well and configure all that stuff with that. That should be the goal, yeah, definitely. Okay, I'm out of time. Thank you very much. Don't forget the evening event, 7 p.m. in the lobby. And then I think we follow up with open spaces, right? Yes. Thank you very much.